Alright guys, so now I'm going to explain how to use the demand function and the supply function of the line to figure out various values and useful numbers that we can use when analyzing supply and demand graphs. So here we have the demand function, A plus BP, and the supply function, C plus BP. We have a table of values with our data for quantity demanded and quantity supplied here, as well as price values. Now, the demand function, the A value, gives us the Q-intercept, and the BP value, slope, and then P gives the value of the price. So, using these values that we have here in our data table, we can figure out the equation for the demand curve. So basically what we do, we substitute n values from our table into the B, which is the slope, and B is the slope, but the thing with curves in for demand and supply is that the x and y values are switched around. This means that the x value depends on the y value. So in this case, the quantity demanded depends on the price. Not the other way around in traditional graphs, where the price depends on the quantity demanded, or the y value depends on the x value. So essentially, what that means is that we have to do the change in x over the change in y rather than the change in y over the change in x. So we have to do run over rise rather than rise over run. So this gives us 300 minus 600 over 4,000, which is the price, minus 2,000. Be careful to use the same values. So then what we do, we calculate this out, which is negative 0.15. And here we have our equation, Q equals A plus negative 0.15p. Now we still need to figure out the A value, so what we do, once again, we substitute in possible values from our table to figure out the A. So we can substitute in 600, quantity demanded and $2,000 for the price. We calculate it out, and then we figure out that A is equal to 900. So our quantity demanded is equal to 900 minus 0.15p, and that's the equation for this demand curve. Now we do the exact same thing with the supply function, where it is C plus BP equals the quantity supply. I'm going to explain what these values mean. Well, essentially it's the same thing. So C is the point where our line intersects the x-axis, and B is once again the slope of the line, and P is the price. So we do the same thing that we just did before. We grab this from our table, which is this column right here. We plug them in, calculate the price. By 2,000 equals 0.15p, and we do the same thing again. We substitute in two values that we have from our table. So that would be the 500 quantity and the $4,000 price. And we figure out that our x-intercept is negative 100, which makes sense, because you can see on the graph that the line goes down, 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 and it doesn't actually intercept the x-axis on the graph, rather somewhere around here, which would be negative 100. Alright, so now we have equations for both supply and demand. The next thing to do is to figure out the equilibrium price and quantity, which would be this point right here. So what we can do for this is set the two equations equal, the supply equation and the demand equation, to get out the equilibrium price. So what we do here, we rearrange, collect like terms. Negative 1,000 equals negative 0.3p, and we get that the equilibrium price is equal to just above $3,000, which makes sense if you look at the graph, because right here, in between 3,000 and 4,000, this looks like about $3,300. And then we just simply sub in this price value into any of the two equations that we have to figure out the equilibrium quantity. I use the supply equation, and then you calculate this out, and we find out that the equilibrium quantity is 400, which makes sense because we can see right here that the equilibrium quantity is just at the 400 line perfectly. Alright, now what we need to do next is figure out, well, what happens when there's a shift in demand or a shift in supply. In my example here for scooters, when the price of gas went down, the demand for scooters went up. So I'm going to explain a shift in demand here to the right, which indicates an increase, which I've already got graphed out here. So how do we change the equation when the demand increases? Well, as you can see right here. The demand increases, so there's a shift to the right, hence the A value or the Q-intercept increases. So remember, the Q-intercept is the X-intercept here. It makes sense that if the demand shifts to the right, the line would intersect the X-axis at a later point. So what we do, we simply change the Q value, the A value. So before my demand equation was Q equals 900 minus 0.15p. Now I can change that to 1100 instead of 900, so by 200. And then I get the new equations, which is this right here. So the line would probably intersect the x-axis somewhere around here, far off. And yeah, that's how you manipulate supply and demand equations.